like to briefly explain LeetCode number 83, remove duplicates from a sorted list. You're given the head and you want to delete all the duplicates, but you actually want to preserve the duplicate node. So you're not preserving the duplicates, you're just preserving the node that the value of the node that gave you the duplicates. So here, as you can see, we have 1, 1, 2, 3, 3. We removed the duplicates, but we actually preserved one of them. Sort of one of the instances of the duplicate nodes. And so let's take a case here. Suppose we had, let's say, 2, and then, suppose we had some duplicate values, let's say 3 and, another 3, and then let's even add another 3 here. And then let's suppose we had 6 and 9. Remember, this is sorted, so it has to be in non-decreasing order, or increasing order rather. And suppose we just had, a pointer here. Let's call it n1. Now, as soon as we so what is our check to see if there's a duplicate value? And the check is, if n1.val, if the value that the node holds is equal to n1.next.val, then we have a duplicate. So for this particular case, n1.next, the value of n1 is not equal to n1.next.val. So 2 isn't part of a duplicated sequence, right? And so we'll move n1 up, right? So moving n1 up is also, another part of this, right? n1 equals n1.next, right? And so at this point, we do have a duplicated node. This check turns out to be true. n1.val is in fact equal to n1.next.val. And what would we want to do? We would want to delete one of the duplicates, right? So we'll basically say n1.next is equal to n1.next.next, right? So what this allows us to do is it says, okay, n1's next reference is going to point to its successor's next reference. And so the resultant is basically, the resultant looks like this, where n1 is here. And then, of course, we may, the problem is after you do this, so this is an issue, right? So after you do this first operation that we described of overcoming the nodes, or overcoming the duplicate, you actually jump out of the if statement, and then you move n1 up, right? And you move n1 up, okay? And then suppose you came back up again and you say, okay, is n1.val equal to n1.next.val? It's not. Move n1 up. So you see how we're actually not catching the duplicate values. So so basically what you want to do is you want to say, while this is the case, keep deleting all instances, keep deleting the duplicate values. So, while n1.val is equal to the next one in line, so the 3 here is equal to the 3 here, move n1's next reference to 3, right? And then we produce this. And again, it makes a check, is the next guy in line, is n1's next reference pointing to a duplicate? And it is, right? So you end up overcoming the successor. So 2, 3, 6, 9. And as you can see here, now this condition is falsified. The next value in line is in fact not a duplicate. And so then it's safe to move n1 up, right? And then of course we're eventually gonna, keep moving it. And then we want to stop when, so while n1 is not null, we keep performing, this enclosed operation, right? But there's only one problem with this code, and the problem is that when you're doing n1.next.val, that could be problematic, because suppose you were given this arrangement, right? Okay, n1.next.val is equal to n1's val. And so what do you do in this circumstance? You overcome it, right? So the next reference of n1 is now pointing to null. So you end up generating this. And then you ask yourself, when n1 is here, you ask yourself, is n1.next.val equal to the equal to n1.val, right? So you end up doing this check. Is n1.val equal to n1.next.val? So you actually end up doing null.value, right? No, there's no such thing as null.value. So you actually want to add an additional check here that basically makes sure that n1.next is not null. Okay, because if n1.next, if you're here and or if you're here rather, it will stop here. It's not going to say, because n1.next is null, so it's not going to let you do n1.next.val. Okay, so that's the basic idea behind this solution. If the head is null, we'll return null. We'll situate n1 at the head. We'll move it up, and while that condition is true, we'll just change the references, and we'll keep moving n1 up.